Hello all, welcome to this new lesson. In the previous two lessons, I showed you how to write C programs to add to integer values, and I also showed you how to write a C program to add to floating point values. And in this lesson, I'm going to show you how to add one integer value and another floating point value, right? So before getting into this program, let me give you a very important concept called as integral promotion, right? So what do you mean by integral promotion, right? So let me explain that to you. In C language, whenever you're working with any of the arithmetic operators, and if you give it two operands, where one operand is of type integer and another operand is of type floating point, then before carrying out this operation, the integral value or the integer value will get converted into a floating point type before performing this operation of addition, right? So this is not just with addition, it is the same with subtraction or multiplication or division, right? So this process where the integer value gets converted into a floating point value before carrying out this operation is called as integral promotion. I'll repeat, whenever you're working with arithmetic operators, and if you have given two operands to any of these operators, where one operand is of type integer and the other operand is of type floating point, then the integer operand will get converted into floating point, okay, before performing any kind of arithmetic operation, right? So in our case, as you can see, if suppose I add one integer value 5 with a floating point value 6.5f, then before performing this addition operation, okay, so the 5, that is the integer value 5, will get converted into 5.0, which is a floating point constant, and then gets added with a 6.5, which is already a floating point value, and then we get the result as 11.5. Right, so this concept of converting or promoting an integer into a floating point value before performing the arithmetic operation is called as integral promotion, right? So having said this, so that is the reason in our program, okay, in this program, as you can see on the screen, okay, I have taken one integer variable to store an integer value of 5, which is here. So a is of type integer, and then I have taken another variable as b to store this floating point value, which is b. As you can see, b is of type floating point value. Okay, and we know that after performing this integral promotion, okay, so when we add two floating point values, we get the result as floating point value, and that is the reason I've taken the variable sum as floating point value, right? So basically we have three variables in this program. One is integer, okay, the other two are floating point types. Okay, so after that I store the value of 5 into a, okay, then I assign the value of 6.5 into b, right, and then I perform the addition. So as I told you again, right, when you add one integer with a floating point value, the integer becomes, or the integer gets promoted to floating point, and when we add two floating point values, we get the result as a floating point value. Now the sum will actually be containing 11.5. Okay, so we have got the sum over here, and then once we get the sum, I'm printing it on the screen using the printf function. Okay, so printf is a standard library function to print certain characters on the screen, right? So printf needs a string. Okay, so printf will start printing each and every character that it encounters immediately after the opening double quote. As you can see here, the output would be, okay, it starts printing from here. It will print sum space of space, and the moment it encounters the format specifier, in our case it is %d, the printf understands that it has to go to the other part of the double quotes and fetch an integer value, because %d is the format specifier for integer value. So it takes the value of a, it keeps it over here, and because our value of a is 5, the output would be 5. Okay, and then it continues printing rest of the characters, and then says, and again it encounters the format specifier %f, so it goes to the other part of the double quotes, it fetches the value of b. In our case, b is a floating point value, and that is the reason we have used %f, which is a floating point format specifier. So b comes and sits in place of %f, I mean the value of b comes and sits in the place of %f, which is 6.5, okay, followed by 5 zeros, 1 2 3 4 5 6. So totally after decimal point there should be 6 digits. Okay, and then again it continues printing rest of the characters. So is, again we encounter one more format specifier %f, go, the printf goes to the other part of the double quotes, fetches the value of sum, it keeps it in place of %f. So as we know that after performing the addition of a and b, we get the value of 11.5. So the output would be 11.5 followed by 5 zeros. Okay, so totally there should be 6 digits after the decimal point. right? So this is what is our output. Okay, so when we add one integer value and other one floating point value. Okay, so the takeaway of this lesson is that whenever you are using arithmetic operators and when you give two operands to it, where one operand is of type integer and the other operand is of type floating point, then the integer operand will get converted into floating point type before carrying out any of these arithmetic operations. And when you add two floating point values, you get the result as a floating point value, right? So that is the reason I made a separate lesson on writing a C program to add one integer and float value. Okay, so hope you understood how integral promotion works. I'm going to make a separate video especially on integral promotion. Okay, so we'll do that in an upcoming video lesson. Okay, so let me also show you how to write this program using dev C++. Okay, so let me first start with a command line which is used for documentation purpose. Okay, so add one int and another float. There's a comment line used for documentation purpose. I have explained it in detail in the previous two lessons. I would recommend you to go and watch that video. This std.h. Okay, this line is called as preprocessor directive, which is used for adding the function prototype for printf. Okay, so let me write the entry point function called as the main function. So this is your main block, and I will take one integer value a to store the first value, that is 5, and then I will take two variables of type float. Okay, so b is to store the second value which gets added with a, that is the first value, and then sum is a variable where it is used for storing the result of the addition of a and b, right? Then let me give values to these. Okay, a contains an integer value, b contains a floating point value. Okay, and sum is equal to a plus b. I'm adding this, and once I add this, I use printf to actually print the values of this. Okay, so sum of percentage d and percentage f is percentage f. Okay, so that is nothing but a b comma sum. Okay, semicolon. So percentage d is a format specifier corresponding to the integer value a. But the second format specifier percentage f is a format specifier which is corresponding to the second value b, that is a floating point variable b. And as we know, after adding one integer and one floating point, we get the result as floating point, and therefore the last format specifier percentage f corresponds to the result sum, which is of type floating point. Okay, so if you're confused with why am I using f over here, it means that whenever I write 5 along with a real number, it means it's a floating point constant, right? So when I don't write f, it means if this is a double value. Okay, so it becomes a 64-bit floating point constant, right? So to make sure that it's always a floating point, I add a f to this real number. Okay, so having said this, let me try to compile this program. I'll go to execute and say compile. So as you can see, the compilation is successful. There are no errors and no warnings. Okay, so it is successfully compiled. So now let me run this program. When I run this program, okay, so I've got my output. Sum of 5 and 6.5 000 is 11.5000. As you can see, our program is successful. It has compiled and run, executed very successfully. Okay, so hope you understood how to add one integer and one floating point, and also I hope you understood the basics of integral promotion. Okay, so in the upcoming lesson, I'm going to show you how to how to handle compile time errors and how to handle compile time warnings. Okay, basically I'll be discussing about the difference between warnings and errors. Okay, so having said that, hope you enjoyed this lesson. Hope you learned something new in this lesson. If you like this video, please don't forget to like this video, and also don't forget to subscribe to my channel and click on the bell icon so that you don't miss out on any of my further updates on this programming series. Okay, so having said that, thanks for watching. Meet you all in the next lesson. Until then, take care. Bye bye. Love you all so much.